So we have to use Zoom to get it onto the screen, so we're gonna record it just so that you can maybe come back to it later if you need to.
You want to do a quick intro to what nap time is? Do you want me to do that?
I'll let you do the back.
All right. So welcome everybody to today's nap time workshop. My name is Michelle Tobias. I work here in Data Lab. I'm a geospatial data scientist here. And yeah, what do you need to know about nap time? We are a community of people that learn together. We do this in a couple different ways. So one way is like today's workshop. Community members teach each other a skill. In this case, we're doing intro to QGIS. The other thing that we do, we alternate weeks with our formal workshops. And then next week we will do what are we calling it?
Community work day.
Community work session. I was like, we've renamed it so many times. So the idea with that is you just come back to this room next week and you work on whatever mappy thing you want to work on. So maybe it's learning more QGIS, maybe for those of you who are grad students, maybe bring your research and work on that. And then there's folks around that, like, if you're really stuck, you can ask questions, but it's not really office hours. It's more like a working on your own with other spatial people who are also grumbling at their spatial data. It's more fun than it sounds. But you're all welcome to attend those as well. So we alternate weeks between work sessions and informal workshops. And so this whole thing happens because of a community. It's not just me who's a staff member who does this as part of our job, but like we have this group called Map Time Davis Council that gets together and plans these workshops and figures out who's going to teach them, when are we going to do it, what makes sense, what does the community need. So you're welcome to give us feedback, and also in the spring we'll have applications to join that board to help plan this whole thing. So if you're interested in that, keep an eye out for the application that will open at some point next quarter. Coming up, we have, I'm going to do a workshop on making maps in R. So if you are an R user or want to be an R user with spatial data, we'll do an intro to that. What else have we got? We've got lightning talks. So if you want to share a 5-minute quick presentation about stuff that you've been working on with spatial data, we're going to do that at some point. We're also going to have career days. So we've invited folks who work in geospatial careers to come and talk and let you ask them questions. We've got people from state and federal government. We've got one of our programmers in the library is going to be here, so you can see like how that kind of works. So if you're on the more programming end of things, we'll have that. What else have we got? Anyway, a good spread of people across a bunch of different industries to talk to for career day. So mark your calendars because it's going to be a good event. We're also going to go to lunch with them, with our speakers afterwards. So you're all welcome to join us for that as well. We're just going to go to Gunrock, no host, pay for your own lunch, but we'll all sit together. So that's the schedule. Any other questions about Map Time Davis and what we're doing? All right, then I think it's time to jump in to our workshop today. Today, our instructor is Lauren Mabe. She has a ton of experience with teaching on campus. She's a PhD student in the Geography graduate group, my alma mater. And this is a really fun workshop. I hope you all enjoy it. Ask questions if you have them. Don't be scared. We will help you. You don't lose points if you don't know what's going on. All right, I'll let you take it away.
Yeah, I have to say I'm a QGIS convert. I learned on ArcMap even, and I'm now, this workshop has like made me a QGIS person. So if you're an ARC person, if you're an Esri person and you're trying to learn QGIS, you're in the right spot because this is how I learned it. But yeah, I'm a PhD student in geography. I have taught a lot. I've taught this workshop a couple times. I think it's a good one to get started. One thing I will note is we are not going to be able to cover all of the things in the workshop. So you will have some homework, which you can come do in the community work session next week. So, but I think we should get going. Has everyone been able to find the workshop materials? It's in the Map Time Davis. If it's not in events yet, because GitHub's being weird, it is in the archive. And you want the intro to QGIS. If you do this workshop and you have a great time, there's also a next steps with QGIS workshop that you can do as well. So just plug in that for everyone. So the overview of this workshop is just to get you, really just to get you comfortable working with data, downloading data, adding it to a GIS platform, and get you comfortable with like the way that QGIS looks, to be honest. You don't need any prior experience. If you have some computer experience, that will be helpful, but not required. I see everyone has a computer, so I think we're good to go on that. And there's some learning objectives. I'll let you read those. I won't read those at you for the sake of time. And then also, if you like this workshop, there is a YouTube channel, and it does have some previous recordings of this workshop. We've been doing this for a few years. I don't think any of the recordings are me, but if you like having someone kind of work through the workshop materials for you, the Map Time Davis YouTube channel is a good place to look.
I think there's one or two of you. There's also me teaching older versions of this, so pick your instructor.
I think there's one of Veronica too from
Oh,
2020.
maybe, yeah. Anyway, lots of options.
Anyways. All right. So before we can even do any QGIS, we need to know what GIS stands for. So GIS stands for Geographic Information Systems. So when people say they are doing GIS, that typically means that they are operating a software that is a geographic information system. So QGIS is the software that we've chose today. There's other common geographic information systems, probably Esri ArcPro is one you've heard of, but even like Google Earth, Google Maps is technically a GIS. Sometimes GIS stands for Geographic Information Science. And that is kind of the framework that we use when we're asking questions about the spatial relationship between things. Since when we're using our GIS software, often we are doing GI science. Yeah, and like it says, it's rare people kind of distinguish the two. The two are kind of mixed together, but it's important for me that people know that GIS is a geographic information system. It is meant to be a software. But colloquially, people sometimes refer to this second one. So QGIS is an open source desktop GIS. So this means it's free for everyone. It's free to use, unlike some other programs that you may have heard of that are not free to use and not free to download. QGIS is free and open source. And it's the official project of the Open Source Geospatial Foundation. So why are we using it? It's free and open source. And I think learning free and open source programs is nice because if you ever leave the university or leave government work, you might not have access to some of the paid programs. Another reason I like QGIS is because it's very robust and powerful. It is a really powerful software. It can do everything that GIS should do. Runs on all major platforms, which I think is not true for Esri, but I could be wrong at this point. Free of charge, frequent updates. There's a robust community online. Like if you have a question, like how do I do this in QGIS? There's definitely a forum. There's definitely a tutorial. There's definitely a website that can help you find that out. And learning GIS is also learning how to Google your problems. When I TA the official GIS class, I require my students to Google 2 things before they email me, because learning how to Google your problems is doing GIS. It also has plugins with all sorts of any kind of plugin you might need. QGIS probably has it. Multiple languages used around the world. I really like it. It's a good platform. I'm definitely a convert from other platforms. So that's my QGIS spiel. We're feeling good about it. Do we have it downloaded? I feel like I should have started with that. That's
in the process.
okay. It might take a while,
Yeah.
but either way, just following. If you don't have it downloaded yet, just watching is to me sometimes more helpful, because the workshop materials are all available to you and you can run through those on your own or in community work sessions next week. So while it's downloading, some things that we need to know about spatial data. Overall, there are 2 main types of spatial data. There is vector data and raster data. And knowing the difference between the two is very important when using spatial data. So vector data is for discrete objects. It is for things that have boundaries. Vector data is always going to be points, lines, or polygons. So something like, I don't know, the state boundary of California, that's most likely going to be a vector, right? It has clear lines that bound it. Something like a river is often going to be represented as a line, right? It's you're either in the river or you're not, right? A tree might be a good point, right? This is where the tree is. And you could make, you can make the argument that like, I don't know, the tree branches out and therefore we need to make it's actually a polygon, but that's not the point. The point of vectors is they're discrete objects. You can think of these as almost categorical variables if you're do other types of stat work. The other type of spatial data is a raster. So rasters are essentially surfaces. So rasters are good for representing things that happen everywhere. Something like air temperature or elevation is another common one, right? Rasters are like a picture where they are composed of individual cells, and each cell or pixel holds a piece of information. So the elevation at this particular point is X. This elevation at a point 30 meters to the left is Y and Z and so on and so forth. So it's like a grid of information. And you can also, you can represent discrete objects as rasters, but that's sometimes not a great idea. You can also represent continuous things as vectors, right? I think like topographical maps are like a really common way to do that. Might be a good idea for cartography, often not a good idea for analysis. So these two data types, vector and raster, are your main ones that you'll be using. All right. So now that we know our types of data, let's download the data. Hopefully we've done this. If you have not, it is in this box folder, and you will want to download the entire folder at once. It'll come as a zipped folder. In this folder, we will find 5 data sets. We will have a digital elevation model, or a DEM, of San Francisco. So that's elevation. What do we think that's going to be a vector or a raster?
Raster.
Woo, good job, y'all. We will also have streets. Vector or raster on that one? Vector. Most likely lines. It is lines. We'll have trees. This trees data set is actually neither a vector or raster. It's actually going to be a CSV. And we're going to turn that into a vector as part of this workshop. We also have seismic hazard zones and the boundary of San Francisco. I'll just tell you, those are going to be vectors. Those are going to be polygons. All right. So if learning how to Google things is a major part of GIS, learning to put your data somewhere you can find it is also a fundamental aspect of learning GIS. So for me, when I download things on my computer, it goes to my downloads folder. You should not work out of your downloads folder. I should make you all say, no, I will not work out of my downloads folder. If you need to do that today, it's okay, but don't do that. And don't work off of your desktop either. You should have a folder for your projects or your class or whatever you're doing. So I have a GIS projects folder because I do GIS, but maybe you have like a research folder or a class folder or something. So we have our data downloaded. It's in a zip file. You can copy it. I always cut for some reason, but let's cut and paste that into our working folder, that you know where that folder is and you can find that folder. You can either make a new one or put it in a random class or something, but you also can work out of your downloads if you need to, but you should not.
It's like an organizational question.
Mhm.
Do you ever, I don't know if you find yourself like working on the same data in R and QGIS sometimes, and like, cause I have an R project folder, and I'm like, should I put it in there, or should I put it in GIS projects, or should it like?
You can totally put it in your R projects. And when we do the GIS data in R, or the making maps in R, you can do both.
Okay.
So put this somewhere you can find it. It can be somewhere you've been working recently. It can be a new folder that you've created. If you're really unsure, you can leave it in your downloads, but please don't. All right. The important thing is you can find the data. And the reason for this is because your computer's actually dumb. Your computer doesn't know what it's doing. It only does what you tell it. So you need to be able to tell it the correct thing by knowing where your data is. I see a lot of students just use the search bar to find their documents these days, and that will not fly in GIS work. Okay, do we have it downloaded? Anybody not have it downloaded? Give me like a thumbs down. All right, you don't have it downloaded yet?
It's having issues, so.
Yeah.
It is okay to admit that things aren't working right. We don't want to leave you behind. So feel free, like, if we've got a spot where Mabe is like, are you good? And you're like, no, I'm not. Let us know. Like, that's how we're gonna learn better. So,
Maybe I'll pull the brain my computer over to get help.
yeah, if you think it's something you want a second opinion on.
All right.
Yeah.
I will give you permission to work out of the downloads if it's taking a while to download.
That's right.
All right. Once we have it downloaded, we're gonna go forward slowly so we don't lose anyone. It is a zip folder. Your computer can't really, well, it can unzip things, but let's not have it unzip things. Let's do it manually ourselves. So let's unzip the folder so you right click on it. On a Windows, it is extract. I don't know what Mac version would be.
You just double click it.
And it unzips.
Yeah.
Okay, either way, we need it to be a regular folder, not a zipped folder. It'll ask you where it wants to go, I always just let it go in the folder with the name, because why rename things if we don't need to? And we now have, oh, and for some reason mine's in another folder. We're just gonna,
Yeah, Box does that. It's annoying.
we're just gonna let that happen. So here is our data. I'm gonna give you a little overview of file types while we let some people catch up. So our DEM SF, that's gonna be our DEM, our digital elevation model. And that is a file type called a TIFF file. That's pretty common for rasters. There's other types. I can't think of any right now. I don't use rasters very often. I'm not gonna lie to you. And when I do, it's always a TIFF, but that's how gonna be one of the ways you know that's a raster. The other thing is the ones that we know are going to be vectors. So one of the most common vector forms is called a shapefile, SHP. But you'll notice I have, for the seismic hazard zones, I have 4 seismic hazard zone files. So shapefiles have friends, and it's important that you keep them with their friends. Because each one of these files is essentially a different part of the data set, and QGIS will merge those together when you load it. So if you ever need to move an individual shapefile around, you have to move all 4 of its friends. The SHP and the SHX, those kind of work together to be the actual like geometry of the object. For some reason, mine's like an open office spreadsheet. It might be like an XML or something like that for you.
Oh, it's probably a PDF.
Or a DBF, it might be a DBF for you. That's going to be the data associated with it. So, you know, that would maybe include like the names of the hazard zones and the type of hazard zone and things like that. You also have one that's called the PRJ file. That's the projection. We don't cover projections too much here, but a projection is, we have a spherical Earth and we need to flatten it into a map. There's many different ways that we can flatten that Earth. And so the projection is basically telling the data set, this is the way that we have flattened the Earth. Because flattening the Earth in different ways makes different shapes of the Earth. I'm sure you've seen, if you've never seen The West Wing and they have the cartographers for justice, and they're like, we need to stop using Mercator projection. That's what it's talking about. Anyways, okay. Now that you've had an overview of data sets, is everyone feeling good? We have some data, we know where it is, we have QGIS maybe.
I have a quick question. Should you ever edit that PDF file? Just go in there and edit it on your desktop?
No, don't edit the DBF file. If you need to edit the data that's associated with your shape files, you should definitely do that within GIS. Do that within QGIS itself. You can do that within R or something like that, but do not open this file and edit it itself. Cool. Okay, we have some data. Let's get going here. Let's start QGIS and open a new project. I probably should have done this beforehand because it takes a while to open QGIS. It's a big program. I have 3.4. I don't know what you have. If you've downloaded it recently, it should be the same. There haven't been like major updates. And if it takes a while, that's very normal. Like I said, it's a big program. It's very powerful. Okay. So once you have it open, you have QGIS open, you will see, once you start working in QGIS, you'll see, different projects you've already done. I don't know what that is. Stop doing that. Oh, that's my layers title now. But for us, we're going to start a new project. So new empty project. Double click on that. And this is QGIS. Welcome. Your actual, like, I gotta move some stuff down. Sorry, you guys can't see this, but I got stuff in the way. Your actual like toolbar up here might look a little different. I've rearranged mine, but you should have all of these buttons somewhere. And we'll go over these buttons, what they mean, or some of the important buttons, and also how to find the things elsewhere. You also here on the left have your layers panel. So as you bring data in, you'll start seeing the data show up here. All right.
They probably also have the browser panel above the layers panel. That's normal. Leave that. You'll want that at some point.
Oh, I might have closed that.
Yeah.
And I'm going to ignore updates because those are for plugins that I don't use anymore. All right. So everyone open QGIS. I know it takes some time. Anyone like, no, wait for me. I will wait. We should wait. Okay, cool. Well, if we want to start working with GIS, we need to bring our data into the GIS. So we'll start with the raster data. We'll start with that. And to do that, we open the data source manager. That's this little like 3 squares with a plus. If you want, you can also do layer data source manager. And it looks like for me, it's Control L. I would assume it's Command L on Macs, but I could be wrong. So we've opened the data source manager. And one thing that's I personally really like is that the data source manager, you have to kind of tell it what type of data you want to bring in at a time. I think that's good. I think the more that you are telling your computer exactly what to do, the better, because then you know what's happening. So since we're doing our raster data first, we want to tell the computer, let's go find some raster data. So you click on the raster button over here. If you know the full file path to get to it, like let's say you're using R or something, you can copy and paste it. I prefer, since we're in a GUI, we're in a graphical user interface, to do that. So these little 3 buttons over here is our browse button. That will open the browser. So this is why you need to know where your data is saved so that you can go get your data. So for me, it's through the GIS folder. For some reason, we're in 2 folders. And you want to go get the data. So I have all of them shown up because I've told it all files. We could also do all supported files. If you do all supported files, it'll kind of shrink that to only raster files because it's looking for rasters right now. So that might be a helpful way to ensure you have the right data set. And you'll see there's 2. There's like this like tiff.ox. We can ignore that. QGIS will deal with that on the back end. When we want to add our dem, we just need the single tiff. So go ahead and click on that, hit open. It'll ask you for some options. That's above my head. I've been using QGIS, or I've been using GIS for years. I don't know what any of it means. Accept the defaults and hit add. There we go. We've added our first data set. So this is a DEM, a digital elevation model. This is pretty much what all DEMs look like when you bring them in. So this is of San Francisco, and you can kind of see the shoreline here, right? The ocean's, the lowest elevation, so it's just all black. This is Marin. Is this Mount Tam? Wow, I'm from Kansas. Is this Mount Tam? It might be. But that's a raster. Once we have some data in, there are some ways to zoom around. So you can scroll out. Or scroll up for me, I guess. That'll zoom out. Scrolling down, zooms in. When you have the little hand, If you don't see the little hand cursor, you can select it here. To pan. So that'll let you like click around and move around. Some other ways to zoom, there's this pans the map canvas to selected features is also helpful. So you select the feature you want to go to, you go to this little 4 arrow guy. And it is already the way I wanted it. So let's get rid of it. Okay, that's not working. That's not what I think it is. Oh, my bad. It's the zoom full. Sorry. It's a little magnifying glass with the arrows. That'll put it full size to your largest thing. You can also use the little zoom in. You're like, oh, let's zoom in on Mount Tam. That might not be Mount Tam, but I've decided it is. You can do that. You can also kind of go the other way and zoom out using that. But I always just kind of scroll to zoom around. And then when in doubt, you're like, wow, this is not doing what I want it to do. When in doubt, go to the hand. That'll help you move things around how you want it. We're feeling comfortable kind of navigating in GIS. Yeah, and that's the type of thing, like it kind of, it'll start coming naturally the more you use GIS, when to use the buttons, when to just zoom, things like that. All right, so now we need some more data. Now we need the shape files. Let's bring those in. The shape files are going to be the vector data. And when you're looking for data, like let's say online, and you know something should be a vector, you're looking for county boundaries, city boundaries, something like that, and you're like, this clearly is going to be a vector data. Just typing like thing I need dash shapefile will often bring it up.
Even if it's not a shapefile, like Google starts to learn that like a geo package and shapefile are started synonymous. And so just shapefile seems to indicate to Google look for spatial data that's vector. So it's like Phoenix, like the main brand.
All right, so to add more data, we go to our data source manager. Woo. And this time we know it's vector data. We go to the vector button. And we go to our browse tab. This is pretty much what you're going to do every single time you need to add some data. There are other ways to add data if you need to do a lot of data sets that's quicker, but that type of thing is beyond our scope. So let's go to our browser. Typically when you browse for something once, QGIS remembers it and will go back to that same place. Sometimes it doesn't though, so always double check. Like mine, I think is in the right place, but just in case, I'm gonna go all the way through my file path. And again, I have all files selected, but if you know that you're looking for vector data, you're looking for a specific type, you can do all supported files, and that'll bring it down to your vector data. All right, so for here, I know I said that you need to keep the friends together, right? Shapefiles have friends. QGIS knows that already. So when you want to add a shapefile, you can just click the SHP. You can probably just click one of the other ones, but I always just click SHP. That's always worked. So let's start with the seismic hazard zones. So click the SHP, open, again, gives you some options. Defaults are fine. Hit add. And then it starts asking about transformations. Yours might not, I don't know, mine does. The transformations, this is where the projections come in. So the computer is just asking you if, let's say, the computer is asking you, how have you flattened a spherical Earth into a piece of paper map? QGIS, this one actually is where QGIS is smart. So another one, you can just select the defaults. If for some reason you add 2 data sets and they are in very different places, and you're like, what is going on? It's most likely a projection issue. And that is something that Data Lab or MapTime Davis can help you fix.
Totally. Come see me.
All right. Actually, oops. If you do what I did and added it twice, super easy to get rid of. In your layers panel, you right click and remove layer. So if you accidentally added it twice, you only need one. So that's how you can get rid of it. And then it'll confirm. And you hit yes. Cool. Do we see our hazard zones?
Yeah.
Not yet? That's all right. If you don't see your hazard zones, but they are in your layers, it's very possible. The way your layers will draw from top to bottom. So if you see something like this, you're like, wow, where are my hazard zones? You want to move them above the DEM. So that's another way that you can control your cartography is just in your layers file, in your layers. You can rearrange. You also can just turn the DEM off. If you're working with lots of rasters, I always recommend turning your rasters off when you don't need them. Rasters are very heavy, right? Each pixel holds a piece of data. And so this particular one's pretty small, so it's not a big problem. But if you have a lot of rasters loaded and every time you move your map, QGIS is going to try to redraw all of those. So I always recommend turning your rasters off if you're not actively using them. So turning them off is just by checking or unchecking this box. All right. We have hazard zones. If we don't have hazard zones, that's okay, because I'm going to show you how to add multiple data at once. Because we have more vector data we need to add. So again, let's go to our data source manager. Let's go to our vector tab. Let's browse for our data. And if you missed your seismic hazard zones, you can add them here again. We also need our shoreline. So let's add that. Then you can hit Control to add multiple at once. So for me, I only need the shoreline and the street center lines. If you missed your seismic hazard zones or accidentally deleted them, add those here as well. Yes.
I've heard that there's some like alternatives to shape files and some people prefer those. Do you have any opinions on using shape files or other?
I personally don't have any opinions.
Okay.
I'm fine with shape files. There are KMLs, which is Google Earth's and version. I actually think those are worse. They don't hold as much data. And there are other forms of vector data that aren't shape files, aren't KMLs. And Michelle will
I
talk
have
about that.
strong opinions. So, shapefile is technically a proprietary format. It's, the only reason we have access to it is because someone hacked it, and then everybody said, oh, I guess we'll share. Because someone got into it and figured it out. Like, there's only so many ways to structure spatial data and make it make sense. So, so it's technically a closed format, and so I think there are better formats now that are open. Like I use geo packages whenever I can. There's some really good advantages to that. They kind of work like databases where you can have multiple layers in a geo package, but you can also just put one in there and that's fine. And also those can hold raster data too. So I would tend towards geo package if you need a binary format, like shapefile's binary. It's kind of like a Word document's binary. You want a format that's human readable, GeoJSON is good for that, but those files are only, they get really big really fast. So if you have a lot of data, GeoPackage is going to be better. But shapefile is fine, but it's annoying to keep the entourage together for a shapefile, like all of the .shp, whatever else.
It's friends.
Yeah, SHX, DBF, all those things. So I personally prefer GeoPackage when I can, but anything that's working for you is good. So don't stress it. And if somebody sends you a shapefile, don't like sneer at them. You can always convert it to a GeoPackage if that's what you prefer. So yeah, getting the data and having all of those things together is more important than format, but GeoPackage is nice. It's a really good open format that everything can read. Sorry, somebody asked for Alex also.
If somebody sends you a shapefile, make sure they send you all of the
Yes.
shapefile
Yeah.
files. It's a very common thing that people forget to include one or more of the extra files, because there can be up to 11 additional files. And then if you want a humorous thing to look at later, Google shapefiles must die.
And then I guess to add on to that, if you're sending a shapefile, it's good to just zip it into a folder before you email it. So that you're not sending, up to 11 files, you're just sending one zipped folder to someone. And that's also common when you download a shape, like a single shapefile, it'll download as a zipped folder because of the friends that you have to keep together.
I would also say be careful with KML. KML is really good for Google-based things like Google Earth, but it doesn't do really well if you have complex attribute tables. So we'll see attribute tables later, but if you have a lot of data associated with it, with each of your shapes, KML starts to break down real fast, so just, KML is a special case, generally I don't use it.
Yeah, like the shapefiles is like, it's like it's like the Word doc of the GIS, like everyone uses it, everyone knows. Sure, latex might be better, but not everyone uses it, so that's the way I would say it.
Yeah.
All right, so we've added multiple by using the control button, or I guess probably command. Let's see. We've opened them. When we hit add, it's probably going to ask about transformations. Nope, we already did that. If it asks about transformations again, just accept the defaults today. We know our data is correct today. We don't have to worry about it. And you'll see the things. That is really ugly. And it just randomly chooses colors. Sometimes those colors are not great. If you want to quickly change the colors, you can just double click on the little icon next to it. And that'll bring up this little color panel, and you can just kind of choose something, a little more street-like here. So that's a quick way to change colors. We are going to talk a lot more about the more robust way to mess with symbology. But yeah, if your roads came in as yellow and you can't even see them, double clicking on the icon next to it is a quick way to change the color. The other thing we'll notice is our shoreline. It's called shoreline, but it is technically a polygon. So, and you can tell because it's a polygon, whereas the lines on the little side here is a line. So if it's got the big box, that's a polygon. If it's got the little line, that's going to be a line. If it's got just like a dot, that's how you know it's just a point. And my shoreline is covering my seismic hazard zone, so I'm going to move my hazard zones up so that we can kind of see those. And for now, I'll turn the streets off because they're distracting. So cool. Do we have our data in? So if we don't, it's in the data source manager. Select the one we need. Go browse for our data. And you can add multiple at the same time by holding control and selecting them. So these are the three that we would need. I'm going to hit cancel because I've already added them. And then I'm also going to hit close because I've already added them, but you would hit OK and then add if you need to add. Cool. Feeling good? We got one more type, and this next one is like, I think, really useful because a lot of times when you get like field data or you get generalized data from the internet, it'll come in a CSV. So let's actually, I'm going to show you what that was. Sorry, I should have opened this beforehand. Here we go. So here's our data in a CSV. This might be something that you're used to working with in whatever your normal stats software is, which might just be Excel, which is a very powerful software. But if your data has, X chord, Y chord, or latitude, longitude, that means that it can be mapped. You can put it on a data set. This isn't an inherently spatial file type, but it is spatial data because it has spatial information. The difference between this X chord and Y chord versus latitude and longitude, you'll see this is like 37.733, whereas this one is 2095, whatever. Those are just the differences in projections, right? So the different ways to unfold a globe have different ways of measuring on there. It's actually not the projection, it's the coordinate reference system. The CRS is different, but we don't need to get into the details here. But that's why there's two different versions. It's basically two different versions of telling things where are in the world. So this is what this looks like, just outside of GIS. Let's get it into GIS using our data source manager. Woo! So this is technically a delimited text. CSV is comma separated values. So that's comma delimited kind of thing. So go to our delimited text. We use the browse button. And for mine, it tells me look only for text files. You might have all files. I think it's useful to look just for text files. And in this one, we want the street tree map. So this is gonna be all of the trees that are on the streets in San Francisco. It's actually, this comes from the city of San Francisco. It's kind of cool that they keep track of all this.
Wow.
When they hit open, now it'll ask you for your geometry definition. So what's the X coordinate? What's the Y coordinate? You want to be able to tell your computer. Okay, so this is already correct, but just so you know, the X field, right? We're thinking on, the coordinate thing that we've done in math problems, making graphs, all the things, X and Y. Latitude and longitude being geographic terms. Here's how I remember it. Everyone has their own way of remembering which is X and which is Y. The way that I remember it is that latitude is fatitude. So the equator is like its belt, is like the Earth's belt, and it is a latitude line. It goes around the Earth, holding it up. And so as you go up in latitude, you're going up the Y axis. So your Y field should be latitude. And then that makes your X coordinate longitude. Some people just memorize that, but for some reason, for me, latitude, fatitude, it's the equator is the belt. And as you bring the belt up, that works for me. I don't know what works for you.
I like latitude, like, cause you climb it like a ladder, so.
Latitude, right? So you're climbing up the Y axis as the latitude goes up, right? So whatever works for you. But for now, make sure that you have X field is longitude, Y field is latitude. And in that case, you're selecting which column in that CSV contains the information. Cool. We want to make sure that it comes in as point coordinates. That should be default, but just in case, make sure you have that. And we are ready to go. Let's add it. For me, that's about the transformation. We're going to let QGIS do its thing and hit OK.
I don't have the option to add.
Yeah, I'm saying it says the CRS must be selected for me.
Oh, let's find out. Let's do it together.
That's a good warning, because you want the CRS selected.
All right. So that's going to be in here, right? Where you tell it what CRS. And in this case, you can I usually say do the project CRS. So this is the CRS that the rest of my data is using is the project CRS. Are you guys able
Doing something
to?
strange on the screen.
Oh, what's going on? Uh-oh, we got a lag.
The internet is.
All right, I'm going to describe this. You know where we told it what the latitude and the longitude was? Right underneath that, you should see a thing that says geometry CRS.
Oh, weird. So let's hold on just a second. The Zoom seems to have crashed. So we might need to reconnect for the screen. Oh, yeah, it's caught up.
There we go. I'm back.
So,
There's the trees.
okay, we're reconnecting. Sorry, pause for that. Catch up if you're like a step behind. We'll just use this time to.
I'm sorry, did you say project or default?
In this case, they're the same. I typically always choose project just to make sure that it connects to, yeah. So you guys must have a newer version that kind of forces you to tell the computer what you want. And that's always good. When you are telling the computer what you want, that's usually good.
Yeah, and in this case, like we want to pick the geometry, like the coordinate reference system. We want it to match what the data is. And this data is latitude, longitude. So any variant of that is gonna be fine. Like WGS 84, 4326 for the ETSG code is generally what I use for that. So that's fine. But you want it to match what your data is, not what you want it to be.
That's true. But that's
why California data ends up in Arizona is when you tell it the wrong projection, because it's what you want it to be, and then it's not what it actually is. So pick the right thing.
Yeah. So this one, we already know our data is correct. We already know that the project WGS 84 is going to be correct. But yeah, like Michelle said, if you choose the project one and it turns out that's actually not what your data is, it'll end up in the wrong spot. And again, that's something a map time can help with. Because learning projections is like kind of its own
We
whole
have a
beast.
workshop for that, but it needs a rewrite.
Fascinating that they didn't do this for the trees in Golden Park.
I think that's because that's federal.
Yeah, exactly.
Yeah.
It's just kind of interesting. And then, yeah, the Presidio is not included.
Yeah.
So wait, when it comes to CRS, how do you know it's the right one?
So you will know that because you will have, like, wherever you got your data from should have information, what we call metadata, that is like data about the data. And it will tell you.
Yeah.
Or if it's an email,
So it was like, this is a very important tree.
otherwise you look at the CSV and you're like, that looks like that. Right?
Oh.
But if you need help guessing, I'm happy to help you with that.
Yeah, or it could be that somebody went looking for a particular species of tree and they were not necessarily concerned about.
Sorry, I lost you at some point.
It's like a tree in the backyard.
But we're feeling good? Yeah, projections are, again, and projections and coordinate reference systems are kind of this like whole, it's like a whole workshop on its own. Like I said, it's always just like, do your best. Try some Googling, worst case scenario, data lab and map time will definitely be able to help you out. But when you choose your CRS, you want it to match your data. In this case, we know it's WGS 84, so we can just use the default. Okay, we've all added our data. Okay, let's save. Let's save our project now. You can use save project here. You can also go to project, save, whatever you prefer. And then again, QGIS usually will bring up the folder that you've been working through, but always make sure that you double check and go, you don't have to go through everything, mine would have been correct, but always make sure that you double check that it is saving where you want it to save. You can save this in the same place as your folder, as your data. So since my data is like weirdly in a secondary folder, I'm gonna save it not in the secondary folder, so then I have a data folder, a project folder. Either way, save it somewhere you know where it is, such as with your data. I'm gonna call this intro to GIS. We'll call it QGIS, just to be specific. And I'll put a date on it too.
Thank you.
You will notice that I used underscores. That is a very GIS specific thing. Most programs at this point can handle spaces and whatnot, but generally do not use spaces, do not use special characters in your file names when working in GIS. Or just blanket statement, just listen to me on this one.
In general, don't do it.
Yeah, in general, don't do it, but especially with GIS, don't do it.
There's reasons.
And we want to save this as our QGIS project format. If you're an Esri person, this is the same as an MXD, I believe. Yeah, this is the same as an MXD, so. Cool, and you'll know it's saved because it now shows up with the name we gave it in the corner. Cool. So at this point, you guys have actually like, I know it seems like, oh my gosh, we just opened the program and like added data, but you've actually learned a lot. Like this is like the barrier to get over when working with GIS, is getting your data in and kind of knowing how to work, what data is and where to put it and things like that. So are we feeling good? I'm feeling good. So the workshop has working with raster data. I'm actually going to skip this page because I am now officially signing myself up to teach a whole raster workshop next quarter. So if you want, you should work on this as like extra credit. But also if you want to learn how to work with raster data, there will be a workshop for that. The point of this page here that we're skipping is to turn your, here, let me show the dem again, to show your like kind of weird DEM, like vague gray scale, and it'll help you turn it into what looks like a more natural topographical map. So we're skipping this. Come to community work days to work on this next week, and I'll help you out. But for now, let's work with some vector data instead. So we're going to skip to 11 here. So the first thing is kind of what I quickly showed you. is, so I'm gonna turn my dim off, move it to the bottom. You can even remove it if you wanted at this point, but you don't need to. Is to change the single symbol styling. Oh, I'm also gonna turn off the tree map for now, just because it's quite large. There's a ton of trees, and so it's also kind of heavy anytime you move. So we'll turn that off. We have some hazard zones. We have some street center lines showing. So there's single symbol styling. The quick way is to just double click on the little icon. That'll bring this up and you can change it. But if you're going to do a lot of cartography and a lot of changing styles, you want to have I forgot what it's called. The layer styling panel. So to get your layer styling panel or any panel, you do. And I immediately forgot what I'm doing. I am so sorry, y'all. View menu, there it is. See, you want to do a lot. Often you're just Googling things that you already know how to do.
That's why I put it in the zine.
Yeah. So in your view menu, down at the bottom, you have a panels. And if you lose your layers panel for some reason, this is how you get it back. But you can also add your layer styling panel. So that shows up over here for me. I'm gonna make it a little bit bigger. And so if you're doing a lot of like color changing, a lot of styling of your layers, having the layer styling panel open is super nice because you can just choose what you want to change and then change it. So let's change the street center lines around again.
Excuse me, where did you find this?
Oh, sorry, I usually tell things twice. I forgot this time. I got excited. So it's through view, panels, layer styling.
Okay. Thank you.
No worries. Thanks for stopping me. I got excited. I love layer styling. There's so much you can do in here. Like this is the type of thing, like go explore this on your own. One thing I like about QGIS is, you can click here and it's kind of a simple way. If you click here on simple line underneath, it'll give you like even more options. There's so many options of what you can do. There's different ways to select your colors. So if you click on the color bar here, you can select through all of this stuff. You can select through this type of color wheel. You can just choose default colors. You can even just like pick a color from a sample color somewhere. Come on. Here we go. Like you can sample a color. Maybe I like this yellow or something. Like you can choose that. So that's kind of cool. Oops, pink. But for now, I'm gonna go to just this kind of regular. So we're in our layer styling. We're in street center lines up top. I've clicked simple line. I actually think you can go through the line here too, even. And then where I accidentally turned to pink, I'm gonna click on that. And since I know the color that I want, I'm just gonna type that color in. So it is the little hashtag, and then it's 6 6s. Will give us a nice street gray. And then once you're like in something like this little arrow here will get you out. Okay. All right. So for funsies, let's all choose whatever of your polygons, your shoreline or your seismic hazard zones that you think is ugly. Go ahead and choose that. And change the color, whatever color you want. I want to make mine pretty. Cool. You guys are now doing GIS on your own. You are not following the tutorial anymore. You're styling layers on your own. That's impressive. And yeah, like I said, there's so many options. It's great. It's like so much you can do. You can even like download new plugins. Like, I don't know if you noticed when I had this roads up, I accidentally downloaded this weird like cat trail plugin. So like, I can make my roads look like on cat trails if I wanted. Like you can do all sorts of stuff. Okay. We've changed at least one color, at least the streets following along. Feeling good? Let's keep moving. I want to make sure we get the next part here. So the next part we're going to get to, taking a little bit of a detour into attribute tables. This is, oh, I just closed my panel. Well, we'll bring it back up later. So attribute tables are the data associated, right? Like these are streets. Streets have names, they have speed limits, they have widths, they have all sorts of things. So we want to be able to look at that. So in our layers panel, we go to street center lines, we right click, and then there's open attribute table. And that opens the attribute table. And so this is the same, remember how we kind of looked at the tree CSV before we got started? This is essentially the same thing. It's all of that data associated. So each one of these rows, which are called records in GIS terms, is associated with one of these lines. And with roads and rivers and things like that, it's usually not the whole road, it's like just a segment. So that's why when I like click on this random and select this random line, you can't really see it because that segment's probably really small. If you want to see it, there is zoom map to selected rows. Anytime you see that little yellow post-it note in QGIS, that's kind of associated with like selected things. So like we have a post-it note with a magnifier, that means zoom to selected. So if I do that, you'll see I selected this really teeny tiny road here that is on top of a hill or something. I actually don't really know much about San Francisco. Yeah.
So we're gonna do it in reverse, like select it on the map, and then see it on the attribute table.
Oh, good question. Yes, there is. So before I do that, I'm going to unselect, which is this deselect features from the layer. So we have our little post-it note. You don't have to follow along right now. You can kind of play around if you want. We have our little post-it note with the red, get out of here. That'll unselect. And we can select a thing, if I remember how. Here we go. With this little pointer arrow and a little guy. So mine says select features by area or single click. And if you hit down, it gives you different options. Freehand, radius, polygons. I usually just keep regular. And so you can click on a road. And if you do, there's a way to, hold on, sorry.
Oh, there's move selection at the top. It's like, that's helpful. There's a button that works.
Yeah.
Oh, is it with the arrow?
Yeah, it's like a square with an arrow.
Oh, nice.
It's another option. So just pop the selected ones at the top so you can still see the unselected ones.
Yeah.
That's helpful for proofing data when something's wrong.
Or when we have our little post-it with arrow and I want to select all of these roads here, we can do that as well. And once we look at our attribute table, move selected to top. So you'll see that I have kind of a lot, like 100. We've got like 100 things selected here. So. And then since I randomly selected these and we don't want them selected, remember it's the little post-it note with the red no, that's our deselect. And a lot of these, like all of these have like keyboard shortcuts. If you're like a power user, you know, the keyboard shortcuts are helpful. I use this a lot and I still don't know the keyboard shortcuts, so don't feel bad if you don't. All right. So let's take a look at this, like what things are like. So our rows in GIS are called records. I think that's a little old school. I think most people say rows. But the columns are called fields. That's actually is common. So anytime that GIS is talking about the fields, it's asking about the columns in the attribute table. So let's take a look at our fields. This one's layer. So private streets, private parks. This probably tells kind of where that road is associated. Nhood is probably the neighborhood, right, that it's in. Street name is the street, you know, so we can kind of guess what things are by the attribute table. But when you download data, the website will have metadata. And so that is a explanation of what all of your fields mean. So like this one where it's like multi-geom false. I'm like, what does that mean? Like if you go to the city of San Francisco and you download their roads layer, it'll tell you what multi-geom means.
I think the README also in the data download has where to find all of this, so we're not guessing. But also the terminology for the records and the fields comes from databases, so you just learned database stuff today too. In case you needed another gold star for today.
Okay, so now we can look at the attribute table. What do we do with the attribute table? A big one is selecting by attributes. So like if we know we want all streets in a certain neighborhood, or for our example here, we're using all things by a specific class code. We got too many. Sometimes I'll open the attribute table twice. It's kind of annoying. So I'm gonna deselect anything I have selected. And to select by attributes, you use this select by expression. So again, select is the little post-it looking guy, and then the E math symbol, it has a name. Yes, that name. Click on that with the math symbol. So here is where you will build your expression to select what you want. So we will select everything. I can't remember what the actual website says. What are we selecting first? Anything with class code 1 is what we want to select today. And if you know your syntax of this expression builder, you can just type that in. This is written in SQL. What is this written in?
It's SQL-like. Oh. So it's similar to SQL.
Okay.
When we do the SQL workshop, if you've been doing a lot of querying in QGIS, so they're like, oh, I get this. So we're easing you into databases while we're teaching you QGIS. Okay.
But I don't know how to write in SQL-like language, so we're going to build this using our mouse. So the first thing we will do is open this fields and values table. Remember, fields means columns. And you can see here, it has all of the columns that we saw in the attribute table. So we would know that we want to select by our class code. We're trying to select anything that is class code 1. So you can double click class code and it'll automatically add it with the correct syntax to your builder. Or your function editor, or whatever they call it. Now, we want anything that equals class code 1. So then you can just type equals, but again, I like to click on it. You click on the equals operator, and this will give you lots of different operators. Equals 1 is this one. And then, okay, we can also just type 1, or I'm going to show you this trick. You do need to be a little bit careful with this trick because if your data set is massive, it will take a while to load. But if you have class code selected, you can click all unique and it'll show you your options.
This works with categorical data. If you do this and it's continuous data, it will freak out.
Yeah.
So just be aware, but you can also see the type there. See how like class code has like ABC next to it? That means it's text. It's not like a number. It thinks it's text even though it contains numbers. So if the ones that have like the little 1.2 next to it, that's continuous. Don't do that with those data.
Yeah, that's what I mean. So be careful with the all equal when, you know, but it's sometimes helpful just to make sure that you are getting exactly what the data says. Because sometimes you think it's like, oh, class code 1, but for some reason the data is like inside the data, it's like 1 space. And if you don't put the space in, the computer doesn't know what you're talking about. So that's where the all unique button is helpful. But again, be cautious. If your data set is large, it might take a while to load.
That 10 sample button is nice if you wanted to see what the structure is. It'll pick 10 random ones to show you. So you can see like, oh, okay, this is really continuous data, or like maybe my Like the tree names, for example, are formatted in a really weird way, so getting a sample of 10 of them will show you what that is, and then you can kind of intuit some things about it.
Yeah, I'll show you that later. I actually kind of forgot about that. So anyways, we have our class code equals written. We have our unique. We know we want one, so I'm gonna double click one and that put it in single quotes. So that's the correct syntax.
It's text, so the single quotes is text. If we just needed a number, we wouldn't put quotes around it, but.
And I think in this case, it'll get both, but let's
Yeah.
do it what the computer wants. All right, does everyone have class code equals one? All right. And now we can hit select features. And then I'm gonna close this particular thing. And I'm gonna click my little zoom out to see the whole thing. I forgot that that is not gonna work because there is a weird thing with our trees.
So if you right click on your roads,
There we go.
there's a zoom to layer.
So also, if you hit zoom full and then your whole thing disappears, that usually means there's like randomly a tree in the middle of the Pacific Ocean and it's trying to show you all of that, but like now your data is too small to see. So that's what happened. I know this happened because I've given this workshop. And if that does happen, you're like, why is there a tree in the Pacific Ocean? I don't know what's going on. This is where the zoom to layer is helpful. So in your layers panel, you can right click, zoom to layer, and it'll get you to the layer you want. If you're doing like analysis with data, you'll have to like cut the tree, you'll have to fix the data problem. But we don't need to do that right now. All right, so things that are selected, I forgot to mention, but I think you noticed is once things are selected, they get selected as yellow. You can change that color, but if like you already have something that's yellow, but we're gonna leave it as is.
So you said when selecting using expressions, so you use passcode in quotes equals one in quotes, right? And then press select features.
Yes.
So for me, it says that there's no matching features now.
It's very possible that's a
Yeah, so the
expression
one
error.
has to be in single quotes. Oh, so in QGIS, double quotes means a field, single quotes means text. I never remember which is which, so I just do it one way and see if it works, and then if it doesn't, which I'm going.
Yeah. So sometimes and that's another one where it's like your computer's kind of dumb. Like it doesn't like, you want to tell it class code equals one, but your computer is kind of dumb. And so you have to tell it the way that your computer wants to hear. And again, if you're trying to select things and things are weird and you don't know what's going on, data lab, map time can always help you. Yeah.
So the class codes in the data are already identifying different types of roads.
Yes.
And so that's why I know that one would equal highways
Yes.
in the field, in the table.
Yes.
Okay.
And so your data, your metadata will tell you that. We can also kind of infer this,
Yeah.
right? Like, just knowing like this is a bridge and a bridge is going to be a highway, or this particular bridge is. And we could go through and select other class codes and try to infer what those are as well. But that's how you select by attributes. And once you have your attributes selected, this is a little bit from the next steps. But what you can do is, let's say you only need highways. You're like, I only care about highways. Nothing else matters. Once you have your data selected, you can right click, do export, and save selected features. And that'll help you make a whole new shapefile of only highways. And when you do that, make sure you browse and save it where it belongs. That's always, you have to do that every time with GIS. Like I said, this is getting a little advanced. I'm going off script here. But if you need to map now, it's important to know this. All right, I'm not going to do that, but. And when you want to make sure save only selected features is selected. So, and if you did that, it'll add a new one. And yeah, so that's a great way to select features. We can also use this kind of select by expression to just change the color, change the styling of the layers as well. So that's actually where we're going back. We're going to symbolize layers by attribute. That's our next step here. And then do we have a question?
I'm maybe jumping too far ahead.
All right. I'm gonna keep these selected. I don't think it matters right now. So let's keep it selected. If you close the attribute table, if you click X, the things will stay selected, so. Just window management.
Yes, so I also see there is an option to filter the data. So what's the difference between filter and selected by attribute?
So I think filtering, that's a good question. I believe filtering is just going to show you different data, but it's not going to select the data. And so when you have data selected, you can do GIS functions and GIS tools only on that selected data. But if you just filter it, that just is kind of just allowing you as the user to see. But selecting actually means like, hey, computer, this particular data, part of the data is important, and I want you to do stuff with only this piece of data. Whereas filtering is just like, I want to see this data. So, yeah, that's actually a good question. Thank you. Yeah, the selecting by attributes is like, again, this is like, you just went over another like major hurdle. And you can build some pretty complicated expressions, like we did is a pretty simple one. To just be like, select all from one class code. But you could potentially be like, select all class code 1, so highways, select all highways that go through, you know, this neighborhood, right? Like you can build some pretty impressive selections. And that's going to be part of the spatial SQL next quarter. Yeah.
Oh, so on that note, that's what I was kind of thinking was with the tree maps, like, can I filter out by types of trees
Oh, yeah.
versus species of trees?
Oh, yeah.
Okay.
Yeah.
If that's in the attribute table.
If it's in the attribute table, yeah.
Okay.
So we actually will go over that.
Okay.
Before we go over that, I'm going to unselect all my data using deselect features. And we are going to reopen our layer styling panel. In view, panels, layer styling. We're going to make sure street center lines is view is selected. And instead of single symbol, right? That means all of the streets are one single symbol. We're going to do categorized. And they go away when you switch to that because the computer doesn't know what your categories are. So right here, we switch from single symbol to categorized. Then you have this value section. Where when you click the dropdown, it'll show you all your columns. And we want to go by class code and tell it, make each different class code a different value. Again, you want to be careful with this if it's something like continuous data, because then you will have lots and lots of colors. If you have continuous data, you should do graduated instead, but we have categorical data. It's either a class code or it's not. So we're going to do categorized. Our value is we want to color it by class code. And then down here at the bottom, we hit classify. And that'll show you all the different things. Now, I'm going to leave it here at this, but you can change, like if I double click on our little symbol here, you can change these symbols. If I click the symbol, hold shift, and then, nope, sorry about that. Click the symbol, hold shift, and select multiple. Then right click, you can change stuff for multiple at the same time. In our workshop materials, I'm actually going to skip this because I don't want to do too much manual typing right now. But in our workshop, if you follow the instructions from this point, you can see how we changed the width of the line to show the road while keeping them all the same color. So that's a good way with lines, especially things like roads where like highways are wider than local streets, or like rivers are wider than creeks. That's a good way to show multiple categories as opposed to colors, because streets are generally all the same color. Rivers are mostly the same color. Those are the only two types of lines I can think of right now, but you get what I'm saying. So we're going to skip this because it does require some manual typing, but homework, check this out. The other thing we're going to skip is this rule-based symbology. In this particular example, what it's doing is, have you noticed when you turn the trees on, there's so many trees, you can't even see them. what the rule-based symbology does. Do we need this? No. What the rule-based symbology will do is you can tell it like, only show me trees of a certain species. Or if trees are the species, turn them red, but the other trees turn them a different color and things like that. So we're also gonna skip that for now, I think.
Oh, because it's in the data, plant type.
Yep, and so anything that's in the data, you can color by a specific thing in the data, you can select by a specific thing in the data, you can filter and just view by a specific thing in the data, and all of that is done by building the expressions through the expression builder. So, like for this, so we're gonna do the roads, if we wanted to, we click on our little E, expression builder, we can do fields, let's say we want word class code. Oh, it's already in there. Equals, if I do this, it will only show me one, I believe. Nope, I don't know what I did. Don't listen to me. I'm wild and.
Is this what you mean by don't edit your data in QGIS? Like, if I notice I want to look at all of the loquats, but in some instances, they've identified specific species of loquats. Is that potentially, like, could I break up that in the QGIS to add that data?
Oh, I see what you mean. Alex has maybe the answer.
Yes, there's a whole system for creating new columns or fields,
Mm-hmm.
and they can be calculated. So you can write code to split like the species name out if you want to.
Yeah, and with the loquat situation, if there's like two different varieties, they're, because it's plants and they've got like genus and species here, you could filter just on genus. So like we could write a query that says if the like species field contains this string, and the workshop materials show you how to filter like with wildcards. So in that case, because it's trees, if you just want to see a specific genus and not genus and species. For plant people, this makes sense. Sorry, for non-plant people, they're like, what? But so like we can say like, just give me this particular string and not the whole species name.
And we do cover, that is adding a new field is very simply covered in the next steps to QGIS.
Gotcha, okay.
Which I will plug by the end of this to be like, once you go through this, here's another one you can do.
And definitely, if you have ideas now that like, you've done a little bit of this, if you're like, I really want to learn how to do X, Y, and Z, write it on our sheet there for ideas for workshops, because we're always coming up with other things to do. So let us know what you want to learn and come to office hours too.
But yeah, I mean, we've really learned how to do a lot, like, styling by like categorical variable is like, that's like basically all I ever do. It's about as high cartography I ever get. And like I said, before we move on, I do want to mention, because you notice our legend still says 0, 1, 2, 3, whatever. Here in the layer styling panel, you can change what the legend says. So we know 1 is highways. We can change that and it will show up as highways here. So then when you go to compose your map and you add a legend, it'll say highways instead of 1. Your data still says 1. The value is still 1, but the legend, what is shown, will be highways. And you can go through and change them all and do everything correctly, but I do want to make sure you know that you can change the legend as well. Because 0, 1, 2, 3 is not super descriptive. And again, this is one where I'm like, you should really like play around with the layer styling panel and like learn that on your own, because like there's so much you can do. All right. The final thing I want to do is make sure we know how to select by location, because I think that's really like, that's to me some GIS stuff, right? Selecting by location is a spatial analysis here. So I'm going to close my layer styling panel. We are done with this. When you need it back, it's in the view panels, but we are done with it. We're also going to be done with our street center lines for now. We just worked so hard making them pretty, but we don't need them. Don't remove them. Just click the checkbox. That'll get rid of them, because, you know, now they're like super ugly. They're all weird, crazy colors. This feels like a good time to save as well, so let's save real quick.
The internet is also telling me it's unstable, so we might just. Might get kicked off again.
All right. I'm also gonna skip composing a map again. This will get you to make like a really pretty map when you're done. But I want to skip that because I really think selecting by location is like a major step in GIS. Right, so because most of what we've done has just kind of been like changing cartography, right? You might have exported your highways to a new layer. But for the most part, we've just kind of changed the cartography, added data, selected some attributes.
Yeah,
So let's do like this is like a real GIS analysis, is like selecting by location.
What was this? You'll see, like.
So the first thing we want to do
This guy here.
is we can take a look at our street tree map. We can take a look at the attribute table
Yeah, and like, it's hard to see.
by right clicking on it,
On yours just because.
opening
the
attribute table.
Color is sort of yellow color, so the selection color is the default.
So this is trees that are maintained by the city of San Francisco. We have legal status, we have Q species, which tells us what species it is,
But that's just because you drop on here.
where it is, all sorts of things. We also have this DBH is a tree thing that I learned for this workshop. It stands for diameter at breast height. So how big around this tree is, how big is this tree? So in this analysis, let's pretend that we work for the city of San Francisco. There's seismic hazard zones. We don't want a large tree falling on. We want to see which trees are at risk of falling on someone if they're in a seismic hazard zone and they are very large. So that's our goal here. So the first thing out of that is we need to find large trees, right? Like we don't care if a small tree falls on someone, they'll be okay. If a large tree falls on someone, that's a problem. So first, we're gonna find large trees, any large tree, by selecting by attributes. Right? Because that's an attribute.
Yeah, I think.
We have an attribute of diameter, breast height, so that will tell us
There's a lot of information.
wherever it is.
Where'd
it go? This will tell us if the tree is large or not. So go ahead and open the attribute table. So we can right click. Open attribute table. Mine is, I now have two open. There it is. And so we want all trees above a certain diameter. So to do that, we will select by expression, right? Our little post-it note with our E expression math symbol. That opens our familiar thing. All right, we have a field, we have a column for diameter. So we can go ahead and open our fields and values. And find the one we need, DBH. Double click on it, it'll add to the expression. So that's pretty quick. We've opened the attribute table. We've clicked our little expression symbol. We've opened all of our fields. And we've added DBH. So, and I don't know, I can't remember exactly what the thing is. I'm gonna stick with what it says. Because I don't know what counts as large, not gonna lie. 36 inches or larger, okay. Got all my windows back, sorry, it's probably a better way to do that.
So that's a tree that's 3 feet around.
3 feet around, that's a pretty big tree. So we want something that is where DBH is greater than. So I typed that because it's actually not in our little thing, but it still works. Right, so if the tree is greater than or equal to. And then can we just type 36?
Yeah.
This is the type of thing where sometimes you have to try, if it doesn't work the way you think it'll work.
You can just type in 36.
You can just type in 36, okay, I'll double check, but like, if it didn't work, we would have to try a different method, probably putting it in single quotes.
That would be bad if you, you couldn't just type it. You might need to not have a space between the greater than and equal sign.
Ah, nice.
There you go. So I was looking, there's an error, like you might have noticed there's an error message at the bottom, and so that tells me like, oh, we need to fix something.
Yeah, so if you get this, that means it's not gonna work. And yeah, in my case, it's because I had a space here and QGIS didn't like that.
It's not gonna tell you what's wrong, it's just gonna be like,
Yeah, I think it will actually sort of.
oh, if you put more info, maybe.
Syntax error, unexpected EQ,
Oh.
not very helpful, but
Syntax
hey.
error means you typed something wrong.
So if our DBH, our diameter breast height, is greater than or equal to 36, that will be a large tree. I had to type in the greater than sign, and you could also type the equal sign if you want. Cool, and then when I hit select features, you can see up here, it'll tell you we've selected 4,000 trees. It'll also tell you up here that we've selected around 4,000 trees. We're feeling good? I don't want to lose anyone yet.
Wait, where does it say the 4,000?
Yeah. It'll say right up here,
In the attribute table.
on the attribute table at the top, it'll tell you how many are selected.
Oh,
And there's also this move selected to top button that if you want to look at them, but there's 4,000, so I'm not even gonna look at them. That's too many to look at, so I'm not gonna click that.
thank you.
All right, has everyone's expression worked? Because sometimes expressions don't work. Okay, cool. I'm gonna close this attribute table. They will stay selected. And when I open the street tree map, you can see there are some selected ones. There are all these little yellow ones. Some of them are covered up, but they're in there. Don't worry, there's 4,000 in there. All right, so now we want to like do more with them. We want to do an analysis. So this is where we actually are going to export this as a new layer. We only want the big trees. So to export as a new layer, we right click on that layer. We go to export at the bottom and save selected features as, because we only want to save the big trees that we have selected. Our format, we're working with as your shapefiles. Let's keep working with them, but you can change the type of shapefile if you want, or the type of thing you want. I'm gonna stick with shapefile. I'm a shapefile fan. Your file name, this is, again, computers are dumb. They need to know the full file path. So whenever you're saving something, always go to browse and check where it's gonna save. Because if I had just typed in big trees, save, it would have saved in the documents and I wouldn't have known where everything is. So always go through browse, always make sure you're saving things where they belong. And there's ways to set up your main database and make sure that it goes the right way, but I think I just never do. I always go through. So once you're in where it belongs, I don't remember what the official name is supposed to be. I'm just gonna call this big trees. And you can tell that I'm saving it with all of my other shape files. So that means I'm in the correct spot. Hit save. And we want to make sure save only selected features is highlighted. Down here, you also want to, I guess you don't have to, but down at the bottom, you also want to make sure add saved feature to map is there. Because if it doesn't add to the map, then like, what's the point? But sometimes, if you're doing this a lot, you actually don't need it on the map. So just, it's there. All right. You also, if you really wanted to, you could actually select what columns come with out of the attribute table. I'm fine with taking them all, so we'll just leave it as, but let's say you're like, I don't need all of this extra data. You can actually get rid of that extra data when you do this. So are we feeling good? We have Esri shapefile. We browsed through where it goes. We double checked that our CRS matches what we're using, which is WGS 84. QGIS should do that automatically for you, but just in case. We want to keep all our fields, saved only selected features, and it will add to the map. I'm ready to hit OK. You guys ready? Let's do it. It takes a sec. Cool. And now we have big trees. And for mine, it's this kind of orange. So if I turn the rest of them off, we can see my big trees. That's a little tough to see. Can you guys see that? The colors? Is that okay? Okay. And then I'm actually going to move this above the seismic hazard zones because they're covering it. So now we have big trees, but we only care about the ones that might fall on people. So those are the ones that are in the seismic hazard zones. If they're not in the zone, they're not gonna fall on people, right? So we really only want to select these trees. If you have a few, like if this is like just a little square and you have like two, like you can just zoom in and select those. But we have 4,000 trees to deal with here, so let's use a tool to do that. So we are now in this part down here. Okay, so I don't know, 13, we're kind of in this section here. So this is like real GIS here, guys. I'm being serious. So now we're going to the vector menu and we're getting some tools. I forgot what type of tool, because this is a research tool. Cool. Okay. So our vector menu, because we're dealing with vectors, and this is a research tool. And if you ever forget where exactly to find the tool, you can usually just Google, where do I find this tool? And someone on the internet will tell you. And so ours is select by location, because we are looking for things that are within seismic hazard zones, and we have the location of seismic hazard zones. All right, here we go. That opens this up. And now we have our tool. So we have select features from by comparing to features from. So we are trying to select big trees. So let's change that to select big trees from. And we want the ones that intersect with seismic hazard zones, right? Since we're using points within polygons, you actually could do are within. Knowing which one of these to use is like, again, could be a zone workshop. So, for the sake of it, let's do are within. I don't know, maybe if the tree is like on the edge, it might be okay. We want to select big trees that are within seismic hazard zones.
So in that case, it actually won't matter because points are infinitely small, just like when you think about what a point is. Are within is more important for polygons. So if you have like a big polygon and you were selecting little ones, it intersect would get anything that overlaps. So if they touched it all, but are within would mean that the entire polygon you're selecting has to be inside the other. I think the results will be the same for points regardless, because like I said, points are infinitely small. They're either in or out. They can't be half.
That's true. But for the sake of like human readability, I'm doing are within, right? Big trees that are within seismic hazard zones. And if you click this help, like this will explain all of the difference between all of the types. But for now, this is what we've got. We want to modify current selection by creating a new selection. We actually have nothing selected in big tree, so it'll create a new selection for us. And when we hit run, it'll select those trees. Ready? So now we can see that the ones within the seismic hazard zones have turned yellow. And so now that they're selected, there's lots of things that we could do. We could either just add a new attribute table column that says this is a hazard. We could export these into their own data set, which you don't always want to do. I think officially on the workshop, we are adding a field calculator. Let's go ahead and do that. I think that's a useful thing to know.
So, question, when you click it, you said you did another set of symbols in a different color.
Yes, it's kind of hard to see. I'm sorry. Here, I'm gonna change big trees real quick and you'll see the difference a little easier.
I don't think anything happens on my server.
Right. So all of our big trees are these green ones, and the ones that are within the seismic hazard zones are now selected into yellow. I chose a bad green. You still can't see that.
Select feature from the tree. So that's your big tree layer, right?
Here.
Yeah.
We'll do brown. There we go. Oh gosh, now they're even bigger. Well, they're the big trees, so they should be big. Right. So all of our big trees are brown. Our selected ones are yellow. Those are the ones within the hazard zones. And I can see where you're like, oh, what about that one? It's in the hazard zone. That's just because I made the dot bigger. If I zoom in, here, I'll show you.
The other one, so just drag it and pull it.
When I zoom in, you'll see that that one's actually not in
There we
there.
go. So it's just sitting.
Oh my, it's on the edge.
On top of the points, you couldn't see that.
See, it's actually not in the hazard zone.
I do that all the time. Though. Can't I see this?
No. Zoom selection.
So just make sure if you're not seeing stuff, look at the order of your, layers panel and make sure that you don't have like a polygon on top of your points. That's something I do all the time is have things in a weird order and then I can't see things.
Yeah, yeah, because if we do that, that's gonna cover them. And you can kind of see them on the edges, because again, I mean, my point's really big on accident,
Yeah.
but
If you're not seeing, it's probably they're just hiding.
yeah. So we already kind of selected and made a new layer. So let's real quick before, sort of like our final thing we're gonna do is instead of making a new layer, we don't need like a hazard layer on its own. We just need to mark that these trees are hazardous. So we can do that in the attribute table. So if we open the big trees attribute table, we can see we have some selected. And it is the field calculator, make a new field, all that. Okay, cool. And we have this field calculator button. It looks like a little abacus, a little calculator. And we open that. There's some checkbox at the top, so we only want to update these fields. We only want to say these ones are hazardous. We also want to create a new field, because there's not already, City of San Francisco hasn't decided these are hazardous or not. We have, so we need to add that field. So I can't remember what the official thing says. I'm just going to call this hazard. Or how about is hazard? When in doubt, always be descriptive. Is hazard. No spaces, no special characters. And what type do we want this? If we had like degrees of hazard, we could make it, hazard 1, hazard 2, hazard 3. I think it officially is like the workshop says it's a text that says yes or no, I think. Or in this case, is hazard would be like a Boolean, true or false. So let's go off script a little. Boolean. Uh-oh, this might be a bad idea because I, don't know how to write SQL on my own.
You should be able to just put in
type
whatever
true?
value, so, yeah, just try true,
Yeah,
yeah, because it's a special.
is hazard true, right? This is a hazard, that is true. Typically, if your like column name says like is whatever, like that means it should be a Boolean, but you could make this a string and have it say yes, right? Like is hazard text string and have it say, I think it's a single quote. Yes, like you could do that as well. I'm gonna go back to my original plan because that feels better to me.
Yeah, there's an art to knowing what your future self will understand.
Yeah.
So structure your data for future self.
And if we hit apply, field is hazard created successfully. Oh, okay, well, I already did that. And if we zoom over, we can see is hazard true for our selected ones. If we really wanted to get fancy, we can invert our selection using the invert selection, which is this like half post-it note, right? Go to our field calculator again. Now we're not creating a new field, we're updating an existing field. I'm going way off script here, so I'm kind of going quick.
That's fine.
Is hazard. So we've inverted our selection. These ones are not the hazard trees, and we can make this false. If we apply that, okay. So now, instead of having to select by location every time we want to know hazardous trees, we can now just select by attribute, are these trees a hazard or not? So that's it. You guys, I'm serious, have done a lot, like learning just like what spatial data is at the beginning, putting it on the map. You've changed the way it looks. You've changed the symbology of those data's layers. You've selected by attributes, which is like, that is like a core skill. If you're going to use anything else, do anything else later, knowing how to select by attributes is like super important. You've exported to a new layer, right? You've made the big trees layer another like key. If you're going to move on, you need to know how to do that. And you've selected by location, which is technically a spatial analysis. So you guys are now geoscientists. Good job. Some things that we skipped. So, like I said, I skipped the raster stuff. And so that's going to be changing the raster symbology. Very similar to changing vector symbology, but a little different. I also skipped composing a map, which again is like also could be its own whole entire workshop. And I skipped in the vectors, I skipped the rule-based symbology as well. So I skipped those. You should go back and do those just to get the whole experience. And then if you want more experience, you can go to maptimedavis.github.io. You can go to the archive, and then we have actually another workshop that I've written called Next Steps with QGIS. And that uses the same data. It uses the same data that you've already downloaded. And it teaches stuff we've already done. It teaches joins. So if you have a spatial data set and you have a non-spatial data set that matches, you can actually join those together. So let's say you have your seismic hazard zones, and then you have a separate data set that tells what type of seismic hazard zone. You can connect those. It also does some geoprocessing of vectors. So buffering, clipping, and actually like changing the way that your layers look is going to be covered in this next steps. So that's a plug for that. There's also in the archive like all sorts of stuff like going real far back. So definitely take a look through the archive, see if there's anything that interests you. And moving forward, we have some lightning talks, which you should sign up to do. You don't even like have to, you can either like your lightning talk can just be like, look, I finished the workshop and I'm really proud of myself. Like that super counts. Your workshop, your lightning talk could also be like, hey, I have this data and I don't know if I can do spatial stuff with it. Like, come talk about it and we'll have a little conversation. We'll help you out. Or like, I don't know, you made a map for your D&D campaign or something, like come talk, show it off, like come show me at lightning talks. So super recommend signing up or just coming to lightning talks. I think they're really fun. We also have maps in R, which is going to be a lot of the cartography stuff in R. So if you're already working in R, sometimes it's helpful to just do the mapping there. And then the career day at the end of the quarter, I think will also be really cool to learn how these skills will help you in the future. Is that all the things I'm supposed to talk about? Yes, I think so.
Maybe people have questions.
Yeah, we got 10 minutes. I didn't want to. Oh, one more thing I forgot to do is save. Make sure you save. Question?
Yeah, so we did a lot of these with just like, I don't know, the points and the polygons and stuff. Can you do similar kinds of analysis working with like rasters and polygons sometimes?
Yes,
Yeah.
and that's going to be part of the workshop that I do next week or next quarter with the raster workshop. So let's say you have your DEM and you have your seismic hazard zones and you want to know like the elevation of your seismic hazard zones.
Yeah.
That's totally something you can do
Sure.
in GIS.
Yeah, if you need help with that before next quarter, come see me in office hours for data lab. So if you go to datalab.ucdavis.edu, you can find when our office hours are. Come see me and I'll help you with that.
Awesome. Thank you so much.
Yeah.
So folks, if you did not sign in, please sign in on the sign-in sheet. That's how we prove that you're cool. We should keep doing that. I also printed more deeds. So if you didn't get a deed and you want one, they have to file them over there now.
No, I'm sleeping.
If we wanted to like try this on.
Yeah.
Online, do you have any recommendations for finding that?
Oh, good question. Finding spatial data is its own skill.
Yeah. Well, and like the-
I always recommend like any government is going to have their data available for free. So all of this data we worked with came from the city of San Francisco. Some counties will have data, depends on how rich the county is. Like LA County has lots of data, Yolo County not so much. State of California is the Cal Geo model.
Or whatever you want, I don't really.
Is the state of California's got all of their GIS data available. And every state has their own geo portal, it's just a matter of finding it.
And we actually.
Universities have data that they store, and then there's also just like
Somebody else will know.
what you're looking for, comma, spatial data in Google.
Okay.
There's also, if you want, we did a workshop on finding spatial data a few years ago. That's in the archive.
Maybe that would be one of those cases.
When did we do that?
Exactly.
That's at 110. I'll probably go back to Cottonwood and either